So this two-sided arrow tells us that this is a reversible reaction, since we have the reversible arrow. And what that means is that we have our acid and a base combined to give us these two products. The acid loses the H plus to give us A minus, and then the base gains that H plus to become BH plus. However, at some point there is equilibrium established, and the products turn back into the reactants at the same rate as the reactants turn into products, and so there is no net change as we learned in equilibrium. But if you notice, if we look at the products and we see this A minus, since at some point when equilibrium is established, we have A minus also turning back into HA. What is it doing? How does it turn into HA? For it to turn into HA, it must find H plus. It must accept an H plus. And if it's going to accept an H plus, by that definition, A minus is acting as a base. Similarly, when BH plus will turn into B, what is it doing? It is donating an H plus, and that's why it's turning into B. So it's acting as an acid. What we are just discovering is that while we have an acid and a base on the left side of this reversible arrow, on the right side of the reversible arrow of this Bronsted-Lowry acid-base reaction, we also have an acid and a base. What's on the right side, we call them conjugate acid and conjugate base, while on the left they are just acid and base. The reason why they are called conjugate is because they belong to a certain structure. For example, A minus, the base, we call it the conjugate base, and it belongs to the same structure from which it was obtained, HA. So what we have is a conjugate acid-base pair. The word conjugate sounds similar to conjoined twins. Conjoined, well, not necessarily twins, but you know what conjoined twins are. They are joined together. They are connected together. Similarly, HA and A minus are in that sense not exactly connected, but conjugate. They are conjugates of each other. The acid and the base here are conjugates. So this is the acid and its conjugate base, while this is the base, original base, and its conjugate acid is given here on the right. Conjugate acid-base pairs are what you will find in a Bronsted-Lowry acid-base reaction where you have the reversible arrow like you see here. So here HA and A minus are the conjugate acid-base pair, and BH and BH plus and B are the conjugate acid-base pair for the other compound.